Hi, Professor TA. My name is Yaobin. In this video, I want to show you my project 1. Here is my submission. The source code folder, the greedy controller, which is my controller I upgraded with my code inside of it, and the README. First, I want to demonstrate my game. Before you run a game, you may want to change the delay to 10. In the execution.java, and here's the game for the map 1. You can change to other maps if you want, and I implement the speed limit because sometimes when the ship is close to the target, it needs to slow down to arrive. But when the target is far away, you need to speed up to save time. And I also use two strategies. The first one is when the ship can see the target directly, and that means there's no obstacles in between, and then it just use the target as the waypoint as the target, and then just go with it. And another situation is that there's some obstacles in between, so I use the utility of path funding, and so that's why I have two code parts in my implementation. Here's my code. I just want to walk you through. There are two blocks where I change my code and include the seek algorithm. The basic idea of seek algorithm is it returns the acceleration vector pointing from the ship to the target, and we use the returned acceleration vector in the decision making. For example, this exercise used a line equation to determine if the acceleration vector is located on the left hand side or right hand side. And here's the key logic is that even though we know if we substitute the position plus acceleration vector into this equation, and we get the result, and the positive result means that the acceleration vector is above and the above the line, and the if the value is smaller than 0, it should be below. But we still need another information to determine left or right. So I want to demonstrate clear. If the line or the direction, the ship's direction is pointing to the right side, then above it is left and below it is right. Here's another case. But when the ship's direction pointing to the left, that means it's x, not y. It's x is smaller than 0. So in this case, the above is right and the below it is left. In the code, I basically implement two parts. The first part here is for the strategy of no obstacles, so it directly use uh, the directory to the waypoint. That means it use the waypoint directly as the next target, and then this is the line equation, and pause is the result of the equation. So if the pause is smaller than 0, the target is above the line. But we still need the direction.x to determine if left or right. If it's larger than 0, uh, the direction pointing to the right hand side. So the above is left. So right now we need to turn right. Uh, and another case, we need to turn left accordingly. I also implement the angle limit. Here's another one, basically the same thing, but you just use the next node as get next node. So it does not use the waypoint as a target, but use the target node in the path of the path funding. And the others are the same. And here's the angle limit. Since the every turn is a large change of the angle, I don't want to always turn and change angles. That is not stable. So I only change the angle one. It is not toward the ship is not toward the target. That means that the angle is larger than 30 degree. So the dot is smaller than the dot 85. I just comment on the original implementation of greedy algorithm. So that's it. Hope you enjoyed. You can test it on the other maps. Thank you.